everyone. Welcome back. This is our second week of the linear relation graphing unit, I guess. So we last week we looked at some graphs or linear, right? So when you plot the points, you can see if you were to join them, it's clearly aligned. Now today we're actually gonna look at some problems that actually generate linear relations. Okay, so let's take a look here. So here, worksheet number 2, I guess, practice describing patterns using pictures, tables, and equations. So here's your name, Mr. H, I guess. Okay, for each pattern below, we are going to draw the next step. And then part B says create a table of values or create a table to describe the pattern. C is create an equation to describe the pattern. And then finally, we are going to provide the number of shapes in the object or objects in the 27th step and 100th step. Okay, so basically we're going to generalize it. Okay, so now if we look at this matches, I guess, sticks, you can see in the first step, this is step 1, okay, step 1, step 2, step 3, we can actually, let's record the number of lines, okay? So here in step 1, you can see that's 1, 2, 3, 4. Okay, in step 2, you can see each side now has 2 sticks, right? So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so and then the third one will be, I think you get the idea, that's 1, 2, 3 on each side. So 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so then in step 4, I think it wouldn't be hard to imagine that it's going to be 4 sticks on each side. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, missing one here. 1, 2, 3, 4. So that would be our next step, and in that case there will be 16 sticks. Okay, so I think it's easy. I think you can clearly see that every time moving up a step, we're increasing by 4 sticks, right? Or number of lines increased by 4. So then I think it's easy to imagine that the next one is going to be 20, right? Because we're just going to increase by 4. Okay, now can we find a pattern, I guess, because we are all of a sudden going from step 5 to step 10, and I mean we could keep adding by 4s, but then 27, then that's going to add 4 a few times. So is there an easier way to figure out what step 10, the number of lines for step 10 is going to be? Well, if you can see, step 1 has 4 lines, step 2 has 8 lines, step 3 has 12 lines, and step 4 has 16 lines. I think we can see the relationship here. Simply, the number of lines is simply 4 times the step, right? Because you can see this 4 really comes from 4 times 1, right? And 8 really comes from 4 times 2, and that's 4 times 3, 4 times 4, that's 4 times 5. So I think this would then be 4 times 10, which is 40. And then this would be then 4 times 27, which is 108. Okay, now there's a step 0 here. So, I mean, if you think about it, if going up by a step means increasing the number of lines by 4, that means if we go back 1 step, this would actually decrease by 4, right? So this would be 0. Kind of makes sense. There's no, I mean, each side you have no lines, and then you don't have anything, right? So there's our table values. Okay, and now part C, we are going to actually create an equation. Okay, we are going to create an equation. So L, okay, that stands for our, again, y values, so number of lines, and this is the step. Okay, so step n. So create an equation for this. Well, then the number of lines is simply equal to, you can see here, 4 times 1, right? So 4 times n, the step number, so 4 times n, plus we actually don't have to add anything, so just plus 0. So really you can just write that L equals 4 times n, which we just write as 4n. Okay, so now if we want to write equation in words, again, we don't need to write down plus 0 because it doesn't do anything. if you want to write this in words, then you can say the number of lines. The number of lines is equal to 4 times the nth step. Okay, so it could be the 5th step, 10th step, 27th step, or in the question D, we are looking for how many lines in a 100th step. So then by using this equation, L equals 4n, the number of lines is going to equal to 4 times n, which is 100. Right? That's our 100th step. So this is going to be 400 lines. Okay. So let me just quickly recap. What we do is we look at these 3 shapes. We are going to draw the next one. Okay, and then we are going to count how many lines there are in each shape, and then we are going to look for the pattern. Okay, and from the pattern, then we can come up with the equation. And then using this equation, we can actually figure out how many lines there are, or there's going to be in the 100th step. Okay, so we take what we know, we make it into a table, and we use that table to generalize it to get an equation, and then we use the equation to solve the problem. So that's kind of the process here. Okay, so let's look at the second example. Okay, part A, it says draw the next step. So step 5, this is step 1, 2, 3, 4. I think it's clear, it's labeled there. So you can see in the first step, it's only 1 cube. In the second step, now there are 2 cubes on the bottom row and then 1 on the top, or 1 on the two cubes on the side, right? So 2 this way and 2 this way. In the third diagram, you can see there are 3 cubes this way and also 3 cubes this way. 4 cubes this way, 4 cubes that way. Therefore, our 5th step is going to be, okay, now let's see if we can draw this. Okay. I guess we're going to have 5 cubes, right? So that's 1, 2, 3, 4. I guess that's all you'll see. So that's 4 cubes here. And then we have, okay, this really is testing my my ability to draw 3-dimensional graphs. Okay, and then we're gonna do this. So it's gonna be like, I guess like this. Okay, so we don't need that. It's gonna be like this. Okay, and then we are gonna need 5 this way as well. So that's 1, 2, 3, 4, 5. Okay, and then we are just gonna complete a cube. Something like this. This might be too much. I might need to go down a little bit. There we go. 1, 2, 3, 4, 5. Perfect. Okay, so there's my step number 5. Okay. Hopefully you have fun drawing this. Okay, it takes some imagination, I suppose. Okay. Anyways, so now we can fill in the table here. So step n. So 0, 1, 2, 3, 4, 5. This time we have number of cubes. We're not going to worry about step 0 yet, but you can see clearly in step 1 we have 1 cube. In step 2 we have 3 cubes. In step 3 we have 5 cubes. Step 4, that's 1, 2, 3, 4, 5, 6, 7 cubes. Step 5, that'll be 1, 2. I'm going to use a different color here. Oops. Erased the wrong thing. There we go. Okay, I'll use a different color just to make it a little bit easier. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 cubes here. Okay. So hopefully you see the pattern, right? Each time we increase the number of steps, okay, this goes up by 2, right? Each time we increase 1 step, the number of cubes go up by 2. Okay, it goes up by 2. Now, okay, so but it's not like just 2 times. Okay, so then I guess what we can see, what we can do is we can look at how these three numbers are related. However, it's still kind of not obvious. We can get step 0 now though. Okay, so if again increase one step means increasing by 2 for the number of cubes, that means if we go back down one step, we are going to decrease by the 2 cubes. So theoretically, obviously this is not possible. We can't have -1 cube. But if there was a step 0, then it would be -1. Okay, it would be -1. Okay, so then how does this help us to figure out what happens with step 10 and what happens with step 27, I guess. Okay, so before we do that, what I'm going to do is I'm going to jump to part C, because we can actually come up with the equation now. Okay, you can see this is going up by 2, and in the previous example, this is going up by 4, and you can see this number 4, okay, the increasing by 4 here, this actually turned into the number in front of n. Okay, that is what we call the rate, right? That's how much we're increasing it by. Okay, so same thing here, because we're increasing by 2. Okay, we're increasing by 2 as we increase the step by 1. This will be our n, or the rate. Okay, that's how many we're increasing by. So number is going to be a 2 here. The number in front of n is 2. Okay, in the first equation, the previous page, this is given to us is an L because that represents the number of lines. Here we have the number of cubes, so I guess we can create a variable for that. We can simply call this C, I guess, the cubes, number of cubes. So C is equal to 2n plus, well, we need to look at what we're going to add. Okay, so what we can do is we can actually just simply take a pair. Okay, a pair of numbers. So for example, let's take this pair. Okay, let's take this pair, 2 and 3. Okay, you can pick any pairs you want. It doesn't matter. Okay, so what we can do is we can try it. Okay, in this case, we have 3 cubes. So instead of C, we're gonna write it as 3 equals, okay, so go there, 3 equals 2 times n. Oops. Okay, in this case, the step n is 2. So 2 times 2 plus some number. Okay, so then, okay, I'm gonna move this down here. Okay, so then this tells us that we have 3 equals 2 times 2 is 4 plus some number. Now, 4 adding a positive value is not gonna become a 3. Instead, actually, we need to minus 1, right? So this number is actually gonna be -1, right? Because 4 plus -1, which means, recall from earlier in the year when we did integers, 4 plus -1 means 4 minus 1, and 4 minus 1 indeed is 3. So our equation is going to be C is equal to 2 times n. Instead of plus something, we are going to change that into, well, you know what, we can write plus -1. Okay, or we can rewrite this as C equals 2 times n. Again, remember, plus a negative number simply means -1 or minus. Okay, so again, plus a negative number means you're subtracting. Okay, so C is equal to 2n minus 1. So in words, that means the number of cubes is equal to 2 times nth step. Oh, well, that was weird. Nth step minus 1. Okay, so we can translate this, or we can take this fact and then do it right here. So what if it's step 10? Well, then it is going to be 2 times step 10, so 2 times 10 minus 1. We know 2 times 10 is 20. 20 minus 1 is 19. Okay, and we can do the same thing for 27. So we go 2 times 27 minus 1. 2 times 27 is 54. 54 minus 1 is 53. Okay, so those would be the number of cubes for those steps. Now for part D, the last question, it says use your equation to determine how many cubes there are in the 100th step. So then all we need to do is like what we did for 10 and 27. We go C, the number of cubes, is equal to 2 times the step number, which is 100, minus 1. 2 times 100 is 200. I'll write it down. 200 minus 1 is 199 cubes. Okay, so again, let me just quickly recap. What we did was we look at these 4 diagrams and we look for the pattern, right? So we come up with the 5th diagram and we record the number of cubes, into this table. And then again, we use this table, look for the pattern, we generalize, we use the pattern and generalize it, and we create an equation out of it. Okay, so really the key here is it's increasing by 2. And that really gives us that number right here, okay? That's always the rate. Notice something, okay? In the first example, look, at step 0, we have number of lines being 0. And look, that's a 0 right here. In the second example, when it's step 0, it is -1 for the number of cubes. Guess what? This is also -1. Huh, interesting. Maybe that is always true. Okay, so what I'm going to ask you to do is, well then, there are, I think, 3 questions for the rest of the handout. So I want you to try those 3 questions and then come up with the equation and see if this pattern is always true. This 2, right? This number in front of n is it always the pattern here? Is that the rate? Is it always true? And is this constant value? Okay, that's what we call a constant value. That's one without variable. So does this constant value of -1, does that always comes from this number? When step is 0, is that always the number? Okay, so I want you to give it a try and let me know how that goes. Okay, good luck.